And you can see it like this. In a relational system, in an accounting system, everything fits nicely. Right? Everything has its place. And if it doesn't have its place, it doesn't belong. In medicine, it's more like this. You need somewhere to put almost anything. But that can be practically anything at all. You don't know. You don't even know, even if you try to find out what it's going to be. Because the next day it's changed. Another characteristic is predetermined versus varying partners. If you take any classical administrative system I know about, at least, like accounting, like agendas, mail systems, and so forth, you have a known set of communicating partners beforehand. It's your customers, or it's your banks, or it's everyone with an email address. In medicine, you don't. If you have a hospital in Stockholm, yes, you have the hospitals in Stockholm talking to you and the labs. But you potentially have a hospital in southern France talking to you. It depends on the patient. What happens today is, since they don't reason that way, you can't talk to the hospital in France. Because the system only talks to predetermined partners, which does not fit with how we work in medicine, because we, 80% of the time, we get patients from the regular doctors in the area. 20% of the time, we get them from anywhere in the world. And as an illustration, this is the accounting way of doing things. You know exactly who you're going to talk to. You add someone, you subtract someone. You're never going to talk to them unless you know them beforehand. In medicine, it's more like this. Right? Could be just about anyone, big and small. And not everyone you talk to directly either. It goes through somebody else. Because this hospital in France maybe sent the patient to hospital in Paris and then came to Sweden. So that's another difference. A major difference of data is that medical data is add-only. You never modify. I'm generalizing. Now I'm not 80% generalized, but 99% generalized. If you get a lab report and it needs to change, you don't do that. You send a new lab report with a change. If you write a letter and it's incomplete, you write an addition to that letter, or you rewrite the letter with the completion in it. You don't really go and change stuff. The only thing you do change is like the address to the patient. But then again, you're back in that demographic relational area, and even then I wouldn't do it. I would add the new address, because maybe I still want to know where he lived before. And this is important because it allows you to do distributed systems. There is no need to have the central electronic record of a patient in one particular place, because the only reason to have it centralized in one singular system is because you want to avoid conflicts and contention. That's what you do in accounting, that's what you do in other systems. It has to be here, because if this guy changes, this guy should see the change that has been done and not change to something else without knowing that he changed. That's what happened in these systems. But if you say that the documents, the records, are never modifiable, only additive, this whole problem falls away. If you look at what happens in reality, you have a record of the patient here. He's been to France. He's got his documents there. They are, for instance, a year old. I'm still in my system. I write the new document. His documents are there. They're not here. He comes with those documents. I can add them. It doesn't matter that they weren't there when I wrote a later document. They add to the record, right? And if you think about this, you discover that you can give patients copies of the records. They can go somewhere else and use them. You don't need to hold on to them. You don't need to give that other person access to your database. You can give them a copy. Why? This copy will never change. Maybe something will show up later that shows that this copy wasn't very good. Fine. You have to find a way to notify them about that. But you don't need to force them to use your system, because there's no point to it. And if you illustrate it, I took a Korean laboratory report for some reason. When you have a modification of a report, the first report is wrong, the other one is better. There's no way you can make out because it's in Korean. unless somebody reads that here. That means that the first document needs some way to point back, or maybe it's Chinese, I don't know. Right? Or Japanese. Okay, so I learned something. You need the bad document to somehow link back to the better, to the improved document, and the improved document to point to the one that it replaces. But this can be solved in lots of techniques. That does not mean that everyone has to use the same database all the time. And if you look at reality, you get into something else, which I didn't even mention here, and that is that medical data is practically never time sensitive, in the meaning that if I've examined the patient, patient is gone, 3 days later something changes in that record, there is usually 80%, 99%, never a reason to notify me about that. So, hey, there's something changed with this patient. I say, okay, fine. I mean, interesting to know. I'm not going to do anything. The point where you need to be aware of the record is when you do something with the patient. When you treat the record, when you see the patient, when you operate on, and so forth. The only time you need to be alarmed about the patient, offline, so to speak, when the patient is not there and when you not ask for it, is only in extreme circumstances. Very rare circumstances. It's not worth building a system with a centralized database just for that, which is also a difference with accounting and so forth, where you actually want to get notified of things. Which means that the situation which all these relational systems are built for, they are built for seeing to it that you have no contention in the record. That if two people work on the same records, that nothing bad happens. That's very noble and very nice of them to do, and it's good IT science. But it has very little relationship to the reality, because you will, as good as never, except by accident, see two doctors work in the same record at the same time. Because the patient is usually with one doctor. So this is such a rare occurrence that you should guard against it. It shouldn't destroy your record, but you should do absolutely nothing to make it easier to work in the same part of the record by two doctors at the same time, because it never happens. Unless by accident. And if it does, they can wait 5 minutes. And if you eliminate that requirement, there is nothing left that forces you to have a big central database. You can use distributed documents, because there's nothing left. Another way of looking at these things with never changing or removing data is this. And this is a real example, because I was in Belgium, also I worked with part of an intensive care system. Intensive care is totally different, because intensive care is more process control. And we had this interesting situation, because we were drawing all on monitors, right? And even lab results and calculate results on monitors. And I did the scripting engine to do these calculations. Okay? Anyway, imagine you have a patient in the intensive care. And you see on the monitor, in the table or in the graph, you see, okay, his hemoglobin is going down like crazy. Right? This is the limit for giving blood transfusions, right? So, oh my God, this guy's going to die. So what I do is I give him a blood transfusion. Let's say this is noon, 12 o'clock. But the lab then discovers they did something wrong. So they changed the lab result from this low value to this, because it was a wrong value, right? I've given him blood. So I say, oh my God. So I do a new measurement and it's way too high. And now we're back into bloodletting and so forth. Then my professor comes in and says, what the fuck did you do? You know, with this value, you give him blood. And I say, this was 4 in the morning, I don't remember. You're going to have a problem. I mean, your career can become very limited. Because something changed the history afterwards. You don't want that to happen. So what we did was this. We left the graph here, but the dotted line, saying this used to be the history, but it isn't anymore. This is very important. You cannot remove and change data, because any data in the electronic healthcare record system that could have formed the basis for a decision needs to be preserved. Because otherwise that decision will hang in the air and somebody will hang from the ceiling. Right? And in most systems you don't have this effect. You have the effect that this simply disappears. And then somebody has to think afterwards and try to write it down in the notes why this happened. And nobody will believe them, of course.